Hello again. We are going to talk about a different kind of sequence and series today. Um, so let me just start out with an example. So you should get some notes out, book out and take some notes on this, and feel free to stop it and start it however often you want. So here's my example. We're going to take the sequence 1, 3. Maybe put a little room under here. 1, 3, 9, 27. And kind of look at, what's happening. So you may already kind of realize what's happening. You just got done doing a lot of stuff with arithmetic sequences, that go up by the same amount each time. If you look at this one, this is going up 2. And then to go from here to here, it's going up 6. And then going from here to here, it's up 18. So clearly, it's not arithmetic because it doesn't go up by the same amount. But if we look at the other idea that's happening is to go from here to here, we're multiplying by 3. If you're going from here to here, you're multiplying by 3. Going from here to here, you're multiplying by 3. That's called geometric. Okay, so that idea of multiplying by some common value is geometric. Arithmetic is going up or down by the same amount. So this is more multiplication. So a geometric sequence is one that the next term is found by multiplying previous term by a common ratio. We usually call it R. So geometric sequence is when you take the next term and you find it by multiplying the previous term by some common ratio. If you look back to the example we just talked about, 9 is the previous term from 27. If we take 9 times 3, we get 27. That's the idea behind a geometric sequence. So let's pretend that we have a new example. Let's look at a new example. And let's say that our first term, remember that's the notation for the first term. Let's say our first term is 10. And let's call this one, our common ratio on this is 1/2. And you're told it's geometric. So as soon as you're told it's geometric, you know, oh, I multiply to get the next term. If we were supposed to find the first 4 terms, if we found the first 4 terms, here's what we'd do. We'd kind of go, okay, recursively, we'd say, what we have is we have the first term is equal to 10. So the next term must be 10 times 1/2, or 10/2. The next term must be 10 times 1/2 times 1/2 again, or 10/4. The fourth term must be 10 times 1/2 the first time, times 1/2 the second time, times 1/2 the third time, or 10/8. So if you look at what's happening, That right there, if you remember exponents, that is 1/2 to the third power. So the fourth term is 10 times 1/2 to the third power. So if that's the fourth term, then you can kind of say, oh, well, what if I said, what's the 10th term? Well, wouldn't the 10th term then be 10 times 1/2 to the 9th power? Because you start with 10 and you multiply it by 1/2 each time until you get to the 10th one. You probably kind of see where I'm going with this, where if I said, okay, pause it if you want to, but what if I said, you write an explicit formula for the nth term? An explicit formula would be 10 times 1/2 to the n minus 1. So, when we're now looking at this, remember what 10 was. 10 was that first term. So if you wanted to have a rule, so if we wanted to say, okay, well, let's summarize this. That was great for our example, but let's summarize this. If we wanted to have a rule for all geometric sequences, the nth term is always a sub n is equal to that first term times that common ratio to the n minus 1. So remember, when you're thinking about what this is the nth term. This notation is the first term. This is the ratio. And remember that n is the index. So how many are we talking about? Going up to 15, we put 15 in there. Going up to 14, put 14 in there. So when you think about like what's happening each time, it's interesting to kind of look and say, what are we doing and what can we do with this? Let's go back to that secret problem. Remember, I did that secret problem with you a couple days ago whenever you watched it, that dealt with recursive formulas. And so I got two more examples. So let's go back to that secret problem. So remember the secret problem. And that was the problem where if you know a secret and tell two people on day one, and they each tell two people on day two, and so on. So that's kind of the situation that we're dealing with. You got this secret, and you're trying to figure out, okay, wow, how many people are going to be told on the 15th day? What's going to happen even beyond that? So when you think about what that looks like, is if we were to kind of write out some things. So that day 0, you are the only one that knows this secret. So you're only one person. On that first day, you have told two people. On the second day, they each tell two people. So now we're up to they told 4 people. On that third day, those 4 new people are each going to tell 2 people each. So now we're up to 8. That 4th day, they're each going to tell 2 people. Now we're up to 16. That 5th day, we're each going to tell, those guys are each going to tell 2 people. So now we're up to 32. Holy cow, is this secret growing? You think about it, we've multiplied by 2 here. Here we've multiplied by 2. To go to here, we've multiplied by 2. To go to here, we've multiplied by 2. To go to here, we've multiplied by 2. That means our common ratio is 2. We're telling 2 people a day. So if I said, how many are we going to know on the nth day? Remember, we go back to that first day. Go back to that first day where 2 people were told. And now every day, they tell 2 people. And so if we wanted to figure out, wow, how many people are going to be told on that 15th day? We take 2 people that were originally told and raise that to the 15 minus 1. What you'll find out is that 32,768 people are told on that day. That's a crazy amount. We're looking at a lot of people. We could even add this up. So let's look at a new question. How many people know the secret by the 15th day? So I'm gonna kind of back up and kind of say, okay, well, how are we gonna figure that out? We have this nice little table that we're going through, but now we're gonna ask, how many people know this secret by the 15th day? And I'm gonna actually set up a table, okay? And I'm gonna set up a table, and I'm gonna extend it out. So I'm gonna kind of draw my nice, neat lines here, and what I want to do with it is I want to over here call this n. I'm going to call this a sub n, and we're going to call this s sub n, where the s stands for the sum. Okay? So now let's look at what's happening. We know that on day 0, you're the only person that knows. So there's only one person that knows the original thing. On day 1, you tell 2 people. So now 3 people know about this secret. On day 3, day 2. Day 2 comes along. 4 people learn about the secret. So now 7 people know the secret total, because there's 4 new people that know it. On day 3, 8 people are told the secret. Suddenly 15 total people know. On day 4, 16 people are told, which means now we're up to 31 people. It's a little hard to figure out what the formula is over here for this sum, but I'm just going to tell you that the sum formula is the first term times r to the n minus 1. All that's divided by r minus 1. Now, we could go through and try to figure out exactly how that's made up, but it's better for you to just know that that's the formula, and know that, on a test, I'd give you that formula and I'd say, okay, tell me what's going on. But if you think about this, that means that we have some new formulas here. On the nth day, the first term times a common ratio of n minus 1 people know it. And the sum is the first term times r to the n minus 1 for r minus 1. In our example, you should realize that r is equal to 2. That is our common ratio for this problem. With that being said, then we can really kind of figure out, wow, how many people are going to know this secret on the 15th day? Because on that 15th day, the 2 people that originally were told the secret times the common ratio of 2 to the 15 minus 1, on that 15th day, 32,768 people were told this secret. On that 15th day, the 2 people that knew, common ratio, 15th day, minus 1, divided by common ratio minus 1. And what you'll realize is on that 15th day, 65,534 people know the secret. You might even say it's not even a secret anymore. That many people know it. It's just common knowledge. So you can see how the geometric ones grow a lot faster than what you did with in the arithmetic ones. So I have one more example that you're going to see this type of problem, and you got to kind of know how examples are built, or how geometric series are built. So here's my example. Remember, you pause the video if you need to go back and kind of take a look at what's up there. Go back and watch it again. But here's the question. If in a geometric sequence, the second term is 50, and the fifth term is 3.2, find the common ratio, which is r, and the first term, which is a sub 1. That's what you're supposed to do. Okay, so let me give you a minute to kind of think about what that is. In a geometric sequence, second term is 50, fifth term is 3.2. Find the common ratio in the first term. So here's the way I would do it. It's hard to just dive into this. You know, some people maybe can just dive right in and know exactly where to go. I tend to say, let me take a step back and kind of figure out what information I have and where it fits into my puzzle. So I know there is a first term. I know there's a second term, and I even know the second term is 50. I know there's a third term. I know there's a fourth term, and I even know there's a fifth term. And I know the fifth term is 3.2. So if I think about what's happening, to get from one term to the next, because it's geometric, I'm going to multiply by some common ratio. And then again, I'm going to multiply by some common ratio. And then again, I'm going to multiply by some common ratio. Together, I've multiplied by that common ratio 3 times. What that means is that value 50 times that common ratio 3 times has got to equal 3.2. So let's look at solving this. Solve this like any algebra equation we've ever had. First thing I would tell you to do is divide by 50. So then our cubed must be 3.2 divided by 50. Be good to have a calculator on this one, right? But you can do this because if you remember from when we did exponent stuff back in the first semester, if we want to get rid of that 3, we just raise everything to the 1/3 power. That way, we have r is equal to 3.2 divided by 50 to the 1/3. That's just a number. That's just a number that if you put that into a calculator, what you'd end up with is that ends up being 0.4. Go ahead and try it. Works out to be 0.4. Now, if you know that common ratio, we can back up, right? We can take this and kind of go backwards with it. We can kind of say, okay, this first term had to be multiplied by that common ratio to get the second term. Well, what that means is that value 50 must be the first term times that common ratio. So how do we find that first term? Just divide by the common ratio, right? And if we divide by that common ratio, we end up with the first term being 125. And so we've answered the question, what's our first term? And what's the common ratio? I know that last one was a little confusing, so it might be good to go back, look at that one again, see if you can make sense of it. If you need help, come to office hours. I would encourage you next to go to the next part of the assignment unit and try the problems that I've added on Delta Math or Desmos or whatever I add to the next slide. I don't even think I've made it yet. Good luck. Hope this makes sense. And now it's your turn. See you soon.